Hello, Gnatostomes! Doing experiments is one of the cornerstones of science. Actually putting ideas to the test is the difference between discovering things on paper and discovering things to put in papers. But setting up proper, rigorous experiments is hard. That's why if you look in a good scientific paper, you should see a detailed description of the methodology used and a discussion of its limitations and weaknesses. You should also see a description of how the results were analyzed and justification for the assumptions made while interpreting them, which is just not something that comes natural to most people. So today we'll be taking a look at an example of what happens when someone who has no idea how to science tries doing it anyway, so that we may learn from their mistakes and of course have a laugh. Some of you may already have seen our subject on my Twitter when I first came across it back in February 2016. It's a Facebook post from the page of an organization with the soon-to-be obsolete name Scotland Against Monsanto, which describes itself as a grassroots activist campaign aimed at stopping Monsanto in its attempt to take control of our food with its controversial GMO seeds. Which is kind of a non-issue, since Scotland has already been dumb enough to ban its farmers from using GMO crops. Also, not really sure how the Scottish-born CEO of Monsanto fits into all of this. Anyways, someone at Scotland Against Modern Agriculture decided to do an experiment comparing organic and conventionally grown beetroot and post what barely passes as results on their Facebook page. Let's have a look, shall we, and do a bit of post-publication peer review. And to help me add some authenticity, I have gotten a true Scotsman to read the stupid for us. Take it away, Angus.
I left a cooked organic and a non-organic packet of beetroot in my fridge to see how they would go mouldy.
And we already have our first problem, in the form of a sample size so small that this is effectively a boring and pretty much useless case study on 2 beetroots going mouldy in jars in someone's fridge, otherwise known as the third most riveting thing in the universe, right after a case study on 1 beetroot going mouldy in a jar in someone's fridge and watching already dried paint. Don't get me wrong, case studies can be very useful when you know how to do them, but they aren't experiments and you can't use them like they are. They're usually used as idea generators, starting points for coming up with new hypotheses to test. They're only used as a main form of research within fields like the study of extremely rare diseases where it's simply not possible to have large sample sizes. Considering the amount of beetroots in the world, this is clearly not such a field. The second obvious problem is that we really don't know beet about these roots. I'm not asking you to track down which farm they came from, although that would be nice. I just want to see some basic stuff like how long they were kept in the fridge, if the jars were sealed, the kind of things which could or would affect how beetroot goes moldy in your refrigerator. You know, the doing the experiment part of doing an experiment. But nope, this is all we get before you move on to the results and your interpretation of them.
The organic beetroot is very alive with a white fluffy mould that is growing fast. The non-organic beetroot has a slow-growing, unhealthy-looking grey mould.
For fuck's sake, there's a different species of mold in each jar, you idiot. And guess what? Different species are different. They look different, grow at different rates, and are adapted to eat different things and live in different environments. This is the equivalent of comparing a fluffy white bunny to a naked mole rat and then concluding that the mole rat is unhealthy. That's not how any of this works, like, at all. You can't just make assumptions based on bullshit because they suit your preferred narrative. And let's be honest here, had the results turned out differently, I'm willing to bet my pacifier that you would have told a different story. That's called being biased.
If bacteria wants to eat our food, then that has to be a good sign.
Wait, bacteria? I thought we were talking about molds. You do know that molds are fungi, not bacteria, right? Right? The 2 groups are so different that they aren't even in the same taxonomic domain. Fungi is a kingdom within the domain of Eukaryota, and bacteria are their own domain, also called bacteria. This is as unrelated as you can get without actually being unrelated, as in calling the molds plants would have been less wrong. In any case, how is mold or bacteria wanting to eat our food a good sign? If the food is safe and appropriate for human consumption, then why does it matter that other organisms can or will eat it? Does this mean you think foods like honey or pickles are less good since they won't go moldy very easily?
Bacteria doesn't like chemical pesticides.
So is now a bad time to mention that organic farming uses pesticides too, and it's just that there are different rules for which they can use and when? This is of course just another possibly irrelevant bullshit assumption. Possibly irrelevant because you have no idea if either of the beetroots were actually treated with or contain any pesticides. And bullshit because it's, well, bullshit in a jar. Bacteria, or molds for that matter, aren't affected by all chemical pesticides. Obviously they're affected by some, such as the ones specifically made and used to get rid of them, but most won't really do shit to them. If they did, we wouldn't need pesticides against them, since plants naturally produce pesticides to protect themselves. But the stupidity of your statement goes even deeper than that. Glyphosate, the active compound in the herbicide Roundup, works by targeting a specific enzyme found in plants and microorganisms. Only some bacteria have a version of the enzyme which isn't affected by it. Genetically modified Roundup-ready crops are made by replacing the plant's own version with the bacterial one. In other words, you could say that you can make plants resistant to a pesticide by making it slightly more like bacteria. But in case that's not deep enough for you, then fine, there's more. Bt toxins are commonly used pesticides in both organic and conventional farming. They're named Bt after the organism which naturally produces them, Bacillus thuringiensis, which is a species of bacterium. Still want to go deeper? One way of applying Bt toxins is to simply spray the bacteria on your crops, i.e. you're using a bacteria as a pesticide. That's right, you're so wrong that there are examples of the opposite being true.
I was very doubtful of organic supermarket food, but this experiment have given me more confidence in supermarkets, although I try to avoid them.
What? That's why you did this? Let me get this straight. To test if organic supermarket food is as good as organic food from other vendors, you decided to compare it to non-organic supermarket food. Why not compare it to organic food from, say, a farmer's market? I mean, it would be pointless since both of them have to meet the same requirements to be certified as organic. But at least it would make sense. Well, more sense at least. Certainly more sense than concluding anything based on the flawed interpretation of a single experiment with a sample size of n equal to 1. Sadly though, you weren't alone in thinking this made sense. 17 people liked the post, presumably because they share the same faulty notion as you, that organic food is healthier, better for the environment, and not associated with big corporations. But that's a whole other can of worms. So, there you have it. If you take beetroot and put it in a jar and wait, it goes moldy. What a revelation. Thanks for watching. And thanks to Angus for being willing to read something this stupid. I'm sorry you had to do that. See you next time, Nanostones.